Now, these problems were intuitive. You didn't really need to formally write something down on paper and solve equations using techniques. But not all equations are like that. Some equations have non-whole number answers. So for those situations when we can't intuitively figure the answer out, you want to perform operations on both sides that are exactly the same. And in general, how you do that is looking on the side with the variable and reverse that operation to get the variable by itself. Whatever you do on one side, you have to do on the other. It's kind of like a balance beam. And I would more formally do this sometimes, but my understanding is you guys are a little bit exposed to equations, so I'll spare you that. All right. So here, the opposite of a number, well, you can just go ahead and change the sign to get the answer, and then multiplying reciprocal is very helpful. We're going to look at that in a minute. So just some points to make. Okay, so I'm going to give you an example here, and then I'll have you guys do one on your own. So we're going to have example and then your turn. Example and then your turn 3 times, and then we'll take a break. Okay, so we got this problem. Now, if you're someone who needs a little structure, you can put a line down the middle. And so this is saying the value on the left is the same as the value on the right. So people say both sides are balanced, right? Like a weight balance, you know. Now, if you add the one side, then this goes down, and so you kind of have to add to the other. That way, they're still the same weight. Okay, so I'm going to call randomly on somebody. Sarah, what's the reverse of multiplying 4? What's the reverse operation of multiplying 4?
Divide.
Right. So we look on the side with the variable. We want to divide by the 4 to get the b by itself. We do exactly the same operation on the other side. So then we get this. Now that's, again, a little more formal. This isn't an advanced equation, but that's the idea. Okay, and then notice this is not a whole number. Now, I won't worry about converting this to mixed numerals right now. If you need a decimal, top number divided by the bottom number. Okay? So again, we're just going to go ahead and here's your turn. Okay. So I went ahead and wrote the solution on my board, and so you guys can check yourself. I'll wait about 10 seconds. All right. Now, I try not to go too fast, so you might see me pause sometimes. What I'm doing is counting to 5 in my head. But interrupt me if there's any time when you think you need me to slow down or explain something, okay? So here's what you should get. Now, if you want to convert this to a mixed numeral, put the negative outside of the fraction. I broke the 21 into smaller pieces, one of which is divisible by 8. So the closest multiple of 8 to 21, then you got 5 left over. So this is 2 wholes, and then 5 out of 8, and the whole fraction's negative. And then if you divide top by bottom, negative 21 divided by 8, you get this decimal. All right, so depending on how you guys went about it, that's what you get. Okay? Okie dokie. Okay, we got one more, and then we'll take a little break, and then we'll come back and we'll look at some unit conversion problems. Okay, so we got this problem. Okay, I'm gonna call randomly on somebody. Let's see. I'm trying to call somebody I haven't called on. I think I might have called on everybody. Maybe not. Ariel, what do you think the solution is, Ariel?
I don't know.
You don't know? Okay. Well, see how this means z over 5? What number divided by 5 is negative 2?
-3.
So negative what? So, okay, if you had 2 5s, what number would that be? What would 2 5s get you?
10.
10, right? So negative 10, since we need a negative.
Yeah.
There you go. Okay, now this is a little tricky because, you know, we may not be used to fractions as much, and so just the way this looks sometimes can be confusing, right? That's the thing about math, all these funny symbols, right? So the top number divided by the bottom number is what a fraction means. We usually just use fractions, but that's what it means. Okay, now here's a formal way of doing this. Sometimes we don't have our intuition, so we need a formal procedure. Okay, so I'm going to put a 1 under the -2, because that's still -2. But now you have two fractions equal, and now, look, you can cross multiply. 5 times -2 equals z times 1. All right? Another thing you can do, look on the side where the variable is. We want to reverse dividing by 5, so we multiply 5. Notice you still get -10. And people say the 5 cross cancels that 5. The reason why you can do that is because since you're multiplying these fractions, you can switch the denominators since 5 times 1 is still the same. So the 5 over the 5 is 1. Now people don't do that, but that's why people can cross cancel, because it means the same as this. Again, a little more formal, but understanding why we can do this is very helpful when we get to more advanced problems, right? So we try to keep it simple first. We don't want to be too complicated. Okay, so here's your problem. Okay, I'm gonna call on, let's see. Jaden, what'd you get for your answer, Jaden?
Is it -21?
Correct, it's -21. Right, and again, you can think about it, what number divided by 3 would get you -7. You could always think about that, so -21. All right, now we got a little more advanced of a problem. And why is it more advanced? Because we have a fraction. Okay? And the thing is, what we want to do here is we want to use what's called a reciprocal. All right? So I'm going to go ahead and put a 1 under the 5. That way we have both sides with fractions. And I'm going to call randomly on somebody. Peyton, what's the reciprocal of 3 over 8?
Like, what is it divided?
No, what's the reciprocal? Flip it. 8 over 3, correct. It's correct, 8 over 3. So we're going to multiply both sides by 8 over 3. Why? Because this is now 1. Notice you get 24 over 24. People also say the 8's cross cancel, the 3's cross cancel. And so notice now you get your answer. 40 over 3 equals z. Now no one writes 1, but that's understood. So that's the answer. So you can see this is a case where the reciprocal is very helpful, right? So sometimes we need different tools. Okay, so you guys, here's your turn. Okay. So here's the answer. Now, what I did to turn into a mixed numeral is I picked the closest multiple of 8. And so that gives us 5 left over. So we got 5 wholes, 5 left over. If you divide top by bottom, 45 divided by 8 would have gotten you this decimal. Okay, now sometimes I can get goofy, y'all. I'm trying to pay attention to so much. I might get slippery with my numbers. If that's the case, let us know. It's okay. Call me out if I make a mistake. It's okay. You're not just helping me, you're helping everybody in the class. But so just wanted to say that just in case, because I'm human too. All right, now here's another way to think about it. So same problem. You can put a 1 under the f, because it's still f divided by 1, and then you can put a 1 under the 9. Right, now multiplying two fractions, this is 8f over 5 equals 9 over 1. Now you can cross multiply. 5 times 9 equals 8f times 1, then so 45 divided by 8. So it gets you just another way of thinking about it.